Hello dear students, welcome once again to our channel Maths in Minutes with Priya. Today's topic is Mixture and Alligation Part 1 and this is clip number 32. I had to divide this Mixture and Alligation chapter in 4 parts because the alligation rule can be used in many ways in many chapters like profit and loss, like problem on averages. It can be used in so many ways even for time and speed that to cover all those types I had to split this particular chapter in 4 parts. Watch this till end and you will be amazed how this alligation rule can be applied to various chapters even if you don't know the basics of the chapter. Now some students find time and speed very difficult. Some find calculating profit and loss very difficult. I am going to cover those examples also where we can use alligation rule even if we don't know what is time, what is speed and what is profit. Even if we hate those concepts, still we will be able to solve the examples using the alligation rule. So please watch this part 1 till end so that you will understand this, and then part 2, part 3 and part 4 will be a cakewalk for you. So let's begin. If you haven't yet subscribed to my channel, please do so. It's absolutely free. You can suggest it to your friends also if you like the videos so that they can also get the benefit. For understanding this alligation rule, first let us see one example. With the help of example, I'm going to explain you what is meant by this figure. First let's see the example. A shopkeeper mixes two varieties of rice, rupees 70 per kg and rupees 120 per kg in such ratio that mean cost is rupees 105 per kg. Find a ratio in which he mixes cheaper rice to dearer rice. I have purposely used these words cheaper and dearer. What is meant by dearer? Dearer means expensive. If you know, in government jobs they call it dearness allowance. Dearness allowance means whenever values or costs of things in market increase, the government employee receives some allowance so that they can spend money. So dearness, dear means things which are expensive. Cheaper, dearer, they are opposite words. So if I see here, one rice is 70 per kg and other is 120 per kg. So what our logic says, 70 is cheaper and 120 is dearer. Am I right? So this alligation rule is used whenever there are two types of objects that are mixed and a third object is formed, which is called a mean. So here if you see, rupees 70, rupees 120. This type of rice are mixed and a third variety of rice is formed whose price is 105 rupees per kg. And always remember, this mean price will be between low and high. Here 105 is higher than 70 but it is lower than 120. It always be like this. It has to be like this. If there is a sum, suppose like this, a shopkeeper mixes two rice, one is 70, one is 120, and then the mean cost of the mixture is 125 per kg. 125 is more than both 70 and 120. Then you can straight away say it is wrong data. If they say mean value is 45 per kg, which is less than both, straight away mark wrong data. Don't even try to solve it, because in given option sometimes 3 options are there, 4th is none of this, then 5th is data given is wrong. And if such thing happen that mean value is more than both the values or less than both the values, straight away mark wrong data. Very clear? Now here mean value is 105. It has to be more than lower and less than higher. Very clear? Now let's understand this rule. Here I am saying object 1, object 2. Always two objects are mixed and a mean is found. Object 1, object 2. Left side I have written this is less than mean. On the right side I have written greater than mean. As I said, one has to be less than mean and one has to be greater than mean. So I have written it here. Now what I need to do, I need to take the difference. Less than mean, so mean minus this value. Positive difference. I always need positive difference. Since this is less than mean, I will subtract it from mean and I'll arrive at some value. This minus this. Let me call it y. In this case, this is greater than mean. So I'll subtract mean from this. I always want positive difference. So I won't subtract this value from this value, but I'll subtract mean from the greater value so that I can get a positive number. And then I arrive at this value. Correct? So below object 1, there is some value x. Below object 2, there is some value y. And the formula says quantity of object 1 upon quantity of object 2 is equal to x upon y. So whatever below this will be in front of this. Below this y, that will be here. Quantity of 1 upon quantity of 2 is equal to x upon y. Now looking at face of it, we hardly understand anything. But once we start solving the examples, we understand it fully. So now let's solve the example. Let's apply this formula for this problem. There are two varieties, right? 70 and 120 and the mean is 105. So I'm going to write here 70 and here 120. This is cheaper and this is dearer. And what is mean? 105. So that I am going to write here. This is mean. So same figure. Object 1, object 2. This is less than mean. This is greater than mean. This is mean. Object 1, object 2, less than mean, greater than mean. And what I said, we need to take the difference. Difference between 70 and 105. It is 35. Difference between 120 and 105. It is 15. Always has to be positive. It always has to be positive difference. Now value below cheap, what is it? 15. Value below dearer, what is it? 35. That means quantity of cheaper upon quantity of dearer. That's what I have written here. Quantity of object 1 upon quantity of object 2. That is x upon y. So how will I apply here? This is cheaper, dearer. Quantity of cheaper upon quantity of dearer. What is below cheaper? 15. And below dearer? 35. So this is 15 upon 35. Can I reduce it further? 5 3s are and 5 7s are. So your answer is 3:7. The cheaper rice and dearer rice has to be mixed in the quantity 3:7 so that he can get the mean 105. Find the ratio in which he mixes cheaper rice to dearer rice, and the answer is 3:7. Very easy to apply. Let's solve many other examples of many chapters so that this rule of alligation just gets embossed on your brain and then you can use it easily. A shopkeeper mixes 28 kg of sugar with cost rupees 30 per kg to some sugar with cost rupees 40 per kg. To get mean cost of rupees 33 per kg, what is the quantity of other type of sugar? Now this particular example is based on problems on averages. If you have already solved problems on averages, I have not yet covered it, but this example is from that particular chapter, problems on averages. So it can be solved using principle of average also. How you can solve it using principle of average? 28 kg and cost is 30 per kg, so you can take their product. 40 rupees kg and the quantity you can assume x, and then it becomes 40x. You can add them, that will be total cost, and then you can divide it by 28 plus x in the denominator, and the average cost will be 33. That is the way you solve it using the method which we learn in problems on averages. If you have already learnt it, then you can solve it with that method also. But right now I'm going to show you how alligation rule saves our time and how easy it is to use. So let's use it. Now there are two types of sugar. I'm going to call it type 1 and type 2. Right? 28 kgs of sugar of cost 30. So this is 28 kg and cost is 30 rupees per kg. This is some sugar, so right now I'm writing here X, and its cost is 40 rupees per kg. And what is mean? Mean cost is 33 rupees per kg. This is mean, right? 30, 40, and this is mean. Rupees per kg, rupees per kg, rupees per kg. The units are same. They have to be same. See, units have to be same of this quantity, and this quantity. It has to be same. So they all are rupees per kg. So now I am going to apply alligation rule. 30 and 33. Positive difference is 3. 40 and 33. Positive difference is 7. And what the alligation rule says? Quantity of this upon quantity of this is equal to 7 upon 3. That we saw already. So that means quantity of type 1 upon quantity of type 2. That's the alligation rule. Type 1, below type 1 there is 7, below type 2 there is 3. So this is the ratio in which they will get mixed. But quantity of type 1 is already given to us, that is 28, and x is unknown, so I am going to substitute it here. This is 28 given to us, x we have assumed, and this is equal to 7 upon 3. So how do we find x? 28 into 3 upon 7. 28 into 3 upon 7. 7 1s are, 7 4s are, 4 3s are. So your answer is 12. X is 12. That is the question. What is the quantity of other type of sugar? Type 2 sugar that we have assumed x. So your answer is 12. Wasn't it very easy? See, once you understand how to put it, when you practice, when you solve many examples, solving this type of example will take hardly 5 seconds. I'm telling you, because calculations are very easy. Subtractions, divisions, they are all very easy. Numbers are also small. What the examiner wants to know is, do you know this rule of alligation? Do you know how to apply it? That is the main question, and that's why this type of questions are asked in examines. Very clear? Next example. There are 20 girls in the primary class. Their average weight is 30 kg. They are mixed with 40 boys, and now the average weight of class is 34 kg. What is the average weight of boys? This again you can do with your principles with which you solve problems on averages. You can very well do that, no problem. If you are fast in doing that calculation, you can do that. But right now I am going to show you how rule of alligation is going to save our time. Once you understand this rule of alligation, if you see these numbers, they are so small, orally you will do it. You won't have to draw this figure which I always draw, left side, right side, then circle, positive difference. You won't have to do all those things once you understand it. And then in 5 seconds your answer will be ready, so that you can consume that saved time to the difficult examples. For reasoning always the examples are very time consuming. So once you save time for maths, or even for maths there are some very lengthy examples that take time to even understand the problem. Solving is different thing. So for those examples you can save this time. Now let's solve this example. What is given to us? Girls and boys. So again two types, type 1 and type 2, object 1 and object 2. So here there are girls and boys. Girls, boys. So when I say quantity of object 1 and quantity of object 2, when it comes to girls and boys, what will it mean? It will be number of girls and number of boys, isn't it? Object doesn't mean always non-living object. It can be living object also, like this. Now girls, number is given to us. How many girls are there? 20. And there are mixed with 40 boys, so they are 40. This is given to us. What else is given? Average weight of girl is 30 kg. So weight 30 kg per girl. Weight is 30 kg. Boys, what is weight? What is average weight of boys? That is asked. So I am going to write here X. And what is the mean? Their average weight, when they are mixed, the average weight of class is 34. So this is 34. This is also kg. Kg, kg, kg. Getting it? This is mean. Do you understand how I put this? Positive difference, positive difference. 30 and 34. Difference is 4. X and 34. Now remember this. We don't know which is bigger, whether X is bigger or 34 is bigger, we don't know. But what we always know, that this mean lies between these two quantities. It has to be greater than 1 and it has to be less than 1. That we have already seen, isn't it? Now 30 and 34. 34 is greater than 30. That means it has to be less than X. So X is bigger here. So I am going to write here X minus 34. Got it? Now quantity of object 1 upon quantity of object 2. Here it is 20 and 40. So 20 upon 40 is equal to what? What is below 20? X minus 34. What is below 40? So your equation is ready. Solve it. 20 upon 40 is half. Shift your 4 there. This becomes X minus 34. 2 1s and 2 2s are. So 2 is equal to X minus 34. Bring 34 here. That means X is equal to 36. So average weight of boys is 36. Very clear? Now you can use little bit of common sense here. Average weight of boys is 36 and here average weight of girl is 30. Now when I calculate, if I get X equal to say 80 or 90, so you have to be sure that you went wrong somewhere in calculation. They are primary school children, it is given. And average weight of girl is 30. Can the boy average on an average weigh 80 and 90? Are they grown up people? They are primary school children. So it has to be near to 30. Girls average weight is 30. Boys will be near to 30. So 36 is fine. 36 is fine. So use this common sense. Whenever you find X, if it is very much bigger, it cannot be. So use that common sense. So even when we solve problems on ages, mother's age, son's age is given. Suppose son's age is something 20 and you solve everything and then you get mother's age 5. Is it possible? It's not possible. Even son is 20 and mother is 25. That is also not possible. There has to be some substantial difference between son's age and mother's age, isn't it? And mother has to be bigger than son, at least by say 18, 20, 22 years. Some substantial difference should be there. So whenever you get some answer, apply some logic to it. Don't just blindly go on marking the given options. Please don't do that. Apply some common sense also. And when a student makes mistake like this, and whenever I tell him, dear, it's not possible that son is 20 and mother is 25, then he go, oh ma'am, sorry, मैंने ऐड करने में मिस्टेक कर दिया. अरे मेरे बच्चे, जब तुझे पता है कि ऐड करने में तूने मिस्टेक कर दिया तो 20 एंड 25 ऐसे एज तो नहीं हो सकते ना. सो प्लीज़ बी केयरफुल. सी व्हाट हैपन्स, यू नो एवरीथिंग, यू सॉल्व एवरीथिंग एंड एट द एंड सी हियर ऑल्सो दिस इज x माइनस 34. इधर आ जाता है 34 प्लस 2 इट बिकम्स 37 at the exam pressure. So please be careful. Please be careful. Don't make such silly mistakes because otherwise your all efforts will go in vain. So let's move to next example. Next question is based on profit and loss. We are going to solve it with rule of alligation. A shopkeeper sells one TV set at 7% profit and another TV set at 5% loss. What is the ratio of their cost price if overall he gets 4% profit? Now in this channel I haven't yet covered profit and loss, but many of you might be already expert in solving profit and loss problems, so you can solve it with your own method with profit and loss principles. That is perfectly fine. But here right now we are going to learn how to solve this with rule of alligation. So there may be some who don't like profit and loss. I have this experience of students who keep on telling me that ma'am, profit and loss is very difficult. We don't understand how to calculate profit, loss. Then some are with profit, some are with loss. Sometimes cost price is same, sometimes selling price is same. There is so much confusion. So what you can do is some questions of profit and loss can be solved with alligation, and this is one of them. So let's see how to solve this in few seconds. Now let's put this information in our alligation rule. 7% profit, 7% profit, 5% loss. Now as I said, all three quantities, these two quantities and the mean, all should have same unit, isn't it? Now this is 7% profit, so instead of writing 5% loss, I am going to write it as minus 5% profit. 5% loss is same as minus 5% profit. And what is the average profit? Overall he got 4% profit, so mean is 4% profit, that is mean. So let's find out the positive difference. Difference between 7 and 4 is 3. Difference between 4 and 5, what is the difference? 4 minus minus 5, that is 4 plus 5, so that is 9. Are you getting it? 9 is to 3. So 9 pertains to 7%, 3 pertains to 5% loss. Got it? One TV set that was sold at 7% profit will have cost price 9, and the TV set which was sold at 5% loss will have cost price 3. 9 is to 3, same as 3 is to 1. This can be 30,000, 10,000, 3 lakhs, 10 lakhs, whatever it is, but it will be in the ratio 3 is to 1. Are you getting it? One more important thing when it comes to profit and loss and when you apply rule of alligation. Here we are talking about profits, and whatever we got here, they will be ratio of cost price when quantities are same. See here he is selling one TV set, and here also he is selling one TV set. Both are 1, and that's why whatever we get here is the ratio of cost price. Now if cost price were same, like 7% profit, 5% loss, that is okay, but their cost prices were same, then whatever we get here will be their quantities. That problem we are going to see in part 2, but right now you can remember this. Whenever there is one set here and one set here, so number of quantities are same, that means whatever we get here is ratio of cost price. So ratio of cost price is 3:1. See, it took only 2 seconds and you don't have to write all these things in exams. In exam what you can do, you can see here this is 7 and this is -5, middle quantity is 4, 7 minus 4 is 3, 4 minus 5 is 9. So your answer is ready. You get it, 9 and 3, it's ready, 3:1 in just 2 seconds. Only one care you take, that whatever number is below 7% profit pertains to ratio of that TV set which was sold at 7% profit. So cost price of that TV set has part 9 and whatever was sold for 5% loss pertains to 3. So that quantity is 3. 9:3, 3:1. If the question is other way around, that find the ratio of the cost price of TV set which was sold at 5% to 7%, then your answer will be 1:3 and not 3:1. So just take that care before you mark your answer, whether it is 3:1, 1:3. 9 is below which number, 3 is below which number. Very clear? Right now if you are little bit confused, please don't worry, because understanding this rule of alligation takes some time, but once you understand it, then there is no looking back. All examples become very easy and we are going to cover total 4 parts on mixture and alligation. So by that time you will be an expert. So let's move to next example. A man can walk with a speed of 4 km per hour. He can travel in a car with a speed of 30 km per hour. Naturally, in a car he travels very fast. What is the ratio of time spent in car to time spent in walking if average speed is 20 km per hour? Now this example is based on time and speed. You can solve with your usual way of time and speed, but here let's understand it with rule of alligation and let's save some time. So walk and car, these are two objects. As I said, object 1 and object 2, they can be anything. Here the objects are walk and car. For walking, what is the speed? 4 km per hour. For car, it is 30 km per hour and average is 20 km per hour. Everything is given to us. Kilometer per hour everywhere, so we are fine. Now apply rule of alligation. 20 and 4 difference is 16. 20 and 30 positive difference is 10. Whatever you get here, they are the times. They are, what is speed? Speed is equal to distance upon time, isn't it? Time taken. So whatever comes here, when you apply alligation to the speed, these are speeds. When you apply alligation to speeds, whatever you get here is time. So time spent in walking is 10 and time spent in car is 16. That's the question. What is the ratio of time spent in car? Okay, here they are asking time spent in car to time spent in walking. So numerator is time in car and denominator is time in walking. Below car which number is there? 16. Below walk which number is there? 10. 16:10. You can further reduce it. 2 8s and 2 5s are. So your answer is 8:5. That means for average speed to be 20 km per hour, he needs to spend 8:5 time ratio in car and walk respectively. Very clear? So here what we did, now there is a formula, speed is equal to distance upon time, etc. Did we apply anything here? We didn't apply anything. What we applied is rule of alligation, and this was solved orally in few seconds. So you can save lot of time when it comes to rule of alligation. In next part, that is part 2, we are going to solve problem when there are 3 objects. In this part 1, we solved when there are 2 objects and how we find that ratio. Now we are next time going to find how 3 objects are mixed and how to find that ratio, and also we are going to see other applications of alligation rule in part 2. And in part 3 and part 4, I am going to cover that 2 liquids are mixed or 2 metals are mixed to form alloy. Milk and water, milk is taken out, milk is poured, that process is repeated 4 times. Those type of all questions that are going to be covered in part 3 and part 4, we are there also going to apply alligation rule. So for part 2, we will cover these 3 objects and some more applications of alligation rule. If you haven't yet subscribed to my channel, please do so. It's absolutely free. Maths in Minutes with Priya. So did you like this video and loved the rule of alligation which saves your time? If yes, I'm waiting for your likes, comments and suggestions. So see you next time. Till then, stay happy, stay blessed. Bye for today.